Good evening. This is Group 25. Our product name is Retinonet. So for our problem statement, we already established that diabetic retinopathy is a leading cause of blindness globally, and we also established how important it is to have early detection of the disease at an early stage. So the gap in the existing methods is that they are computationally complex. Then there's also that there's a scarce number of specialists, those are the ophthalmologists that diagnose the disease. Then also there's lack of awareness in diagnosis of the disease, as well as remoteness. This means the areas that cannot easily access this diagnosis services. So the impact is that millions of people face irreversible vision loss, and this reduces their quality of life. So without early intervention, diabetic retinopathy silently steals sight and livelihoods. So our core objective is to enable early detection of diabetic retinopathy, which we already know is very important, and then to improve access in these underserved regions. Now, those are the remote areas I was talking about. You don't have access to the specialists or to the equipment or the devices for diagnosing the disease. Then also empowering the healthcare providers with AI. This is giving them support systems to enable them easily diagnose the disease. Then we are scared to scale impact to save sight globally. So our solution overview, our approach Retinonet uses deep learning to analyze these fundus images, pick out the features that are needed to diagnose the disease, and then give the results. So the data used is, and this is just an example of some of the images of the different classes of diabetic retinopathy, but our main focus is going to be on the mild or early diabetic retinopathy diagnosis. So here, it's just a display of the different models that we worked with before we picked out our final model and how they actually performed in connection to diagnosis of the disease, basing on their accuracy, precision, we call under F1 score. And as you can see, our best performing model was the VIT Swin transformer. So I'll hand over my colleague to take you through the next part of our presentation.
Good evening. Uh, my name is Jude, and I'll take you through uh, the models and the techniques. So we built a number of models, but we selected the Vision Transformer because it had lesser computational costs and effectiveness via dealing with these images. Then the architecture, we have an input layer where we input the image, then the preprocessing model, the AI model output, and we deployed it on Hugging Face. So the implementation details, we used a couple of languages like Python, then libraries, we used PyTorch, TensorFlow, and then OpenCV for image preprocessing. Then the platforms we used Google Colab for training and Hugging Face for development. Hardware support, we use GPU support, that is specifically the NVIDIA Tesla V100 for faster training. So the results and the evaluation, you can see from the confusion matrix that the selected product worked well in the specific 7 classes we had, as seen in the confusion matrix. Then the impact and the relevance of the product. Uh, we have the relevance to Uganda. It addresses screening gaps and late diagnosis, especially in remote areas. Then the global impact, we expect to target Africa and the whole world. Uh, for sustainable development goals, uh, it prevents blindness since we are detecting retinopathy at an early stage. Then it also improves access in low resource areas. Then the target users are clinics, telemedicine providers, government health programs. Then my friend will come and take it.
Hey, my name is Tomelis Rodney. I'm going to take you through the intellectual property and innovation. So the purpose of this is to show how we are going to help us commercialize our product. So first of all, we need a pattern, and this pattern, it's supposed to help us prevent competitors from from using the same model. And then we also have the copyright. We're going to copyright our source code, protect our source code, our user interface, and maybe reports generated by our product. We want to prevent the unauthorized copy of our design and functionality. Then we also have the trademark in the brand name written on it. We do not want someone using a copycat using our brand name to publish similar product. Then the unique and ornament aspects of Retinol's interface and hardware integration, preventing competitors from copying it for the next 15 years. That's also in our pattern. We do not want someone duplicating our system. Then we have competitive advantage. So in the competitive advantage, one of the things, the existing AI models, this is not a groundbreaking idea, what we have implemented, right? There are already existing products that are able to diagnose the diabetic retinopathy, but some of them are in developed countries like the United States. As you can see, the IDXDR it's also patterned by the FDA. So, trying to get these systems to use in our country like Uganda, it's going to be expensive. And one of the things we have is we want to make our product scalable to what? To Ugandans. Yeah, that's what we have in our competitive advantage. Let me take you through monetization and scaling. So basically, we want to have a SaaS subscription. We also want to do licensing and API integration for telemedicine. Then our market size, basically, in Uganda, we have about 500,000 diabetic adults. So that's a starting point. But in the worldwide, the market is valued at about 10 billion US dollars by 2030. That is an estimation. Then we have the SWOT analysis. Our strength it's supposed to be affordable, scalable, and high accuracy. Then weaknesses, we have initial deployment costs. Opportunities, we have the growing diabetic population. Then threats, we have competitors. But yeah, budget estimates, as you can see, we need to get an AI specialist, we need to get an ophthalmologist part-time, we need a legal team, then we need maintain cloud computing services, we need cameras, portable finance cameras, then a training program, software licenses. My colleague will take on from here.
Good evening. So this is a sample demonstration on how our rating note works. So this shows you that I'm browsing through the files. So the person using our model chooses a particular file. They said I've chosen that one. So it's loading. So after it loading, it shows us this image. So it's supposed to diagonalize the image, whether it belongs to one of the 7 classes that we have. So here they have predicted that it belongs to a severe and proliferative diabetic retinopathy. Yes. Yeah. So lessons learned and challenges that we face. There's limited access to diverse retinal datasets from Uganda, then limited computing resources, then imbalanced dataset. So the lessons we've learned from this is that we use data augmentation to help us with the problem of imbalanced datasets. So it's improved our model performance on our small dataset. Also, we are collaborating with local clinics to highlight real-world needs, like cost reduction. In the future works, we have improvements that we are going to make, such as integrated real-time telemedicine features. Then also want to expand our data set with African images. So this is going to improve our accuracy. And also the pilot in Uganda is that if we are working on the scale, that we're going to scale in West Africa. So we're going to target at least 34.2 million diabetic adults by 2040. Yeah, then we're also going to partner with NGOs and governments for a broader deployment. Yeah, so thank you very much.